Good morning, students. As we are doing definite integral now, in this continuation, we will do some another question from exercise 7.11 and some important question from miscellaneous exercise of chapter 7 also. Okay. So now just starting with question number 7, definite integral. Just here, this is the question number 7, 0 to 1, x1 minus x to power n dx. As usual, we will apply the property number 6 here, the upper limit minus function 1 minus x, 1 minus x to power n dx. Next stage, 1 minus x, this becomes x to power n dx. This taking this x to power n inside the bracket, this becomes x to power n minus x to power n plus 1 dx. Now applying the integration here, so this becomes x to power n plus 1 upon n plus 1 minus x to power n plus 2 upon n plus 2. Applying the integration and leave it from 0 to 1. So using the upper limit minus lower limit, 1 minus 0, so first part will be 1 upon n plus 1 minus 1 upon n plus 2 and second portion whole is 0. Further calculation, this taking n plus 1 and n plus 2 is LCM. So this is your final answer. So this was the question here and it is also a good question. Now I am taking some question from miscellaneous exercise also. Zero to pi by 2, 5 sin x plus 3 cos x upon sin x plus cos x dx. Taking I and equation 1. Again, as usual, we are applying the formula, the property number 6 here, that normally using the almost every questions. Okay, 0 to pi by 2, 5 sin pi by 2 minus x plus 3 cos pi by 2 minus x. Same thing applicable here in denominator also, sin pi by 2 minus x plus 3 cos pi by 2 minus x. So it's not here, dx. More simplification, 0 to pi by 2, it becomes cos x, it become sin x. So plus 3 sin x, and denominator part, it is cos x, it is sin x, same thing, sin x plus cos x. This you consider as equation number 2, Now adding equation 1 and 2, this is 2i, and you can see here the denominator part it is sin x plus cos x, same here sin x plus cos x, it is as a LCM, taken sin x plus cos x LCM, and upper side would be 5 sin x plus 3 sin x become 8 sin x, and 3 cos x plus 5 cos x, 8 cos x, 8 as a common, sin x plus cos x dx, limit 0 to pi by 2. Further on, more simplification, sin x plus cos x cancel. Now this is the 2i is equal to 8 dx 0 to pi by 2. 8, so this becomes pi by 2 means 4 pi. So this 2i is 4 pi, it means I is equal to 2 pi. This is your final answer. Okay. One another very interesting questions that is very good for examination point of view. Okay, that is 0 to pi by 2 log sin x. It is long question also, it is very long question. Step by 2 and 3 step applicable here. Now 0 to pi by 2 log sin x. Taking this as a I, equation number 1. Okay, as usual, again we will apply the property number 6 here. 0 to pi by 2 log sin pi by 2 minus x dx. So this become log cos x dx. This you consider as equation number 2. Adding equation 1 and 2, adding equation 1 and 2, it becomes 2i is equal to 0 to pi by 2 log sin x plus log cos x dx. Okay, now applying the rule of integration here, just see 0 to pi by 2, this become log sin x cos x dx. Okay, one more application here, multiply 2 both numerator and denominator inside this log. So this become a 2 sin x cos x, our lower side is 2 sin x cos x become sin 2x. So we can write it log sin 2x minus log 2 dx. Further on 0 to pi by 2 log separated log sin 2x dx minus log 2 dx 0 to pi by 2. Okay, this you can consider as a I1, this portion, and we will do it separately. Here this is log 2 and this become x, so 0 to pi by 2 and I1 minus, it is applying the upper limit and lower limit, so pi by 2 log 2, this is the value of 2i, consider this as a equation number 3. Now we will solve this I1 separately. Okay, so I1 is 0 to pi by 2 log sin 2x dx. Now here we will consider this 2x as a t. We will consider this 2x as a t. Okay, let 2x equal to t, so dx is equal to dt by 2, and for limit this is when x equal to 0, then t is equal to 0, when x equal to pi by 2, then t is equal to what will be pi. So this is become 0 to pi, this portion 0 to I1, 0 to pi log sin t and dx equal to dt by 2. It means 1 upon 2 0 to pi log sin t dt. One more property and a property of differential applying here. Okay, it is twice one property, that is it is an even function, so it become twice 0 to pi by 2 log sin t dt. As I told you, this is very long question. Now, so this I1 this I1 is equal to 0 to pi by 2 log sin t dt. Again applying the property of definite integral number 1, the function t you can change into function x. So this becomes 0 to pi by 2 log sin x dx. You are getting the I. That is equation number 1. That is equation number 1, I. Okay, so I1 become I. I1 becomes I. So apply this I value of I1 here. Okay, you can see here equation number 3, 2I is equal to I1 minus pi by 2 log 2, and value of I is I1 as in equation number 4, I minus pi by 2 log 2. Shift I this side, so this finally I is equal to minus pi by 2 log 2, and that is your final answer. So this is a long question. Step by step you have to do it. Step by step you have to do it. One more question I will tell you. It is also interesting question. Question is question number 10 of miscellaneous. Pi by 6 to pi by 3, 1 upon 1 plus cot x under root dx. And okay, this is you taken as a I. Actually this is a converted form of another question which we have done earlier. Okay, and now to simplify it. When you will simplify it, it is pi by 6 to pi by 3, but change this cot x. Change this cot x to cos x upon sin x. Okay, so this is a root cos x upon root sin x. Further on, you can see here pi by 6 to pi by 3 sin x upon sin x plus cos x. Root sin x plus root cos x dx. Okay, so now next stage, this I become pi by 6 to pi by 3 sin x plus cos x. Now you can consider this as a equation 1. Applying the property number 6 here. Okay, one property, that is upper limit, lower limit is upper limit minus function, that is pi by 6 to pi by 3 sin pi by 6 plus pi by 3 minus x square root upon sin pi by 6 plus pi by 3 minus x square root plus cos pi by 6 plus pi by 3 minus x. This is property number 5 here, and this pi by 6 and pi by 3 become pi by 2, and sin pi by 2 minus x become cos x. So finally this will convert into cos x, and this will convert to cos x. This is also sin x. Finally root sin x plus cos x dx. This is equation number 2. Again the same procedure as I told you that question number 7 of the first very initial question of chapter 7.11. Adding equation 1 and 2, you will get 2I is equal to the here the LCM and the denominator are taking sin x plus cos x root LCM, so it will cancel. So it is pi by 6 to pi by 3 dx. This is your value. Okay, and now applying here. So it is pi by 3 minus pi by 6. So 2I become pi by 6. I is pi by. So this is the miscellaneous exercise of chapter 7. We have to complete it and do it, and further on we will start the next exercise in next period. Thank you.